Welcome back to Common Core Algebra 2. Today's notes are on 11.6, sine and cosine graphs. So exciting, we get to start graphing our sine and cosine curves. So in exercise 1, it says consider the functions f of x equals sine x and g of x equals cosine x, where x is the angle in radians. That's really important to make sure that you are underlining. So by using the unit circle, fill out the table below for the selected angles. Now, folks, I still have to go to my unit circle whenever I'm doing this because I get confused with the ones and the negative ones and the zeros. So this is going to be the 0.10. 90 is going to be the 0.01. 180 is the point -1, 0, and 170 is 0, -1. I still need to do that. So 0, I'm going to start with 0 because my cosine, remember, is my x value and my sine is my y value. At 90 degrees, so this is 0, this is 90, this is 180, and these you should know, this is 270, and this is 360. So at 2 pi, pi over 2, we have 0 and we have 1. At pi, we have -1 and 0. At 270, we have 0 and -1. And at 360 should be the same as 0, which is 1 and 0. All right, now we work backwards. Negative pi over 2 means we're down here, right? We go this way, clockwise, and we get 0, -1. We do negative pi, which is the same as positive pi, which is -1, 0. Negative 270 is 0, 1. And we're back to negative 2 pi, which is 1, 0. So now what they tell us to do is graph both the sine and the cosine curves on the grid shown below. So I'm just going to change my values here. Instead of making this 1, I'm going to make this 1. And as long as you change it on your graph, you can change the scale. So for our sine curve, let's use blue. We'll use the blue pen for the sine. So I'm going to start at 0 because the cosine curve starts at 1. And then it goes down to 0. And then at pi, it moves to -1. At 270 or 3 pi over 2, it's back at 0. And at 2 pi, it's back at 1. And we're going to follow that same curve to the negative side. So we're at 0. We're at -1. We're at 0. We're at +1. Now, these are not straight lines. This is a curve. All right, so make sure that when you do this curve, you're thinking about concavity. So we have this goes down this way and comes up. Notice how I curve coming around. I come down, I come back up. And so this is f of x is equal to cosine x. All right, now we're going to do the same thing for our sine graph. The sine graph, why don't we do that one in red? The sine graph at 0 starts at 0. So I'm going to look right here at 0. So at 0 degrees or 0 radians, it starts at 0. At pi over 2, it moves to 1. Then it goes to 0. It comes down to -1, comes back up to 0 again. And then we do the same thing going negative. So we do -1, come up to 0, +1, back to 0. So our sine curve is going to look something like this. It's a very cool function. All right, so that's going to be our f of x is equal to sine x. So I'm going to slide this up a little bit, and we're going to look at C and D, asking the domain and range. So the domain and the range of this sine and cosine functions are the same. State them below in interval notation. So the domain of both of these graphs are going to go on forever in both directions. So it's -infinity to +infinity, but the range is going to be between -1 and +1. Close brackets because it includes those. All right, so after how much horizontal distance will both sine and cosine repeat its basic pattern? This is called the period of the trigonometric graph. Because these graphs have patterns that repeat, they're called periodic. All right, so basically for both of these, if you look about sine, let's see if I can find a different color. How about yellow? If we look at the yellow, we can see how the sine and cosine graphs, sine starts at 0 and cosine starts at 1. And then the same thing, it stops at 1 and it stops at 0. So you can see that between 0 and 2 pi does a full cycle. All right, so between, let's say, 2 pi completes a full cycle. So we would say the period is 2 pi. So now we would like to explore the effect of changing the coefficient of the trigonometric function. In essence, we would like to look at the graphs of functions that have the form, I'm sorry, I'm reading and I didn't switch it over, y equals a sine x and y equals a cosine x. All right, so it says be sure your calculator is in Radian form when you're doing your tables here. All right, so you can actually put these into your calculator and you can see what they look like. So this is the graph of y equals cosine x, the one that's given to us. And if you remember, it's the same one that we talked about the last time. It starts at 1. Now this time, each one of these is equal to 1. Starts at 1, goes to 0, hits -1, back to 0, ends at 1. So you can see how it's the same curve that we just drew on the previous example. So now it's saying what happens at 3 cosine x. Well, what's going to happen here is, let's pick a different color. How about blue? We'll call this one A. And it's going to give us the same curve, except whenever it's 1, it's going to multiply it to 3. So wherever 1 was, it's going to be 3. At 0, it's still 0. At -1, it's -3. At 0, it's 0. And it ends up here at -3. And the same thing goes for the negative section. -1 is -3. I'm sorry, I went the wrong way. The -3 is here. All right. Then it comes back up to 0 and then to +3. So our curve of A is going to look something like this. And again, remember the curves. All right. So this is A. Using some colored pencils or a highlighter would really be helpful right now. So B, now you see how B has this negative here? That means that when A was +1, it's going to be -1 now. So it's just going to kind of flip-flop. It's going to reflect over the x-axis. So it's going to be -4 though. So if you look at 0, normally 0 would be a +1, but now we're going to multiply that by -4, which is going to bring us down here. The 0 is going to remain at 0. The -1 turns to +1, and you could do this on a table if this is confusing to you in any way. All right, the 0 comes back to 0 on the negative side. Now the -1 turns to +4, and back to 0, and down to -4. So this one kind of cool. This one goes really nice and high, back to 0, come up to 0, back up to 4, back to 0, and down here to -4. So that was B. Now, keeping in mind, let's do C, because I feel like after we just did B, C is pretty easy, except it's going to follow the same pattern, but instead of being at -4, it's going to be at -2. So the zeros remain the same. So +2, 0 remains the same, -2, 0, +2, 0, -2. And make sure you follow the same curve that we just did. Very cool. So that is C. And now the last one is D. And D is, it says 3/2, which is the same thing as 1.5. So we're going to follow the normal curve of a cosine, except this time it's, instead of being at 1, it's going to be at 1.5. So the zeros remain the same. 1.5, 0, 1.5, 0, negative a half, 0, positive a half. So our curve is going to look something like that. And that's our, let's call that one D, even though we didn't do them in order. All right, they're all cosine curves, just with different amplitudes. Okay, we'll talk about that just in a second, as soon as you finish writing all of that down. Don't overthink this. So as we can see, this coefficient controls the height that the cosine curve rises. So the height is called the amplitude that the cosine curve rises and falls above the x-axis. That's the big part, okay? Its absolute value is given the name the amplitude. In terms of sound waves, it indicates the volume of the sound. So in exercise 4, so now we're going to do the same thing, but we're going to use our sine function. So given to us right here is our sine function. So one more time, let's pick a different color. How about this purple one? This beautiful sine curve looks like this. Remember, sine starts at 0, ends at 0, all right, and has 0 in between. So this is the sine curve. So what happens now when we have A being 2 sine x? It means the distance from the x-axis is now, instead of being 1, is going to be 2. So our zeros are going to remain the same, but our height is going to change from 1 to 2. Oops, wrong one. Here. So up, down, follow it all the way around, like that. So this blue is our A. Now in B, same thing happens. We don't have a negative in front, so it's going to follow the same curve, except this time our height is going to go to 4 above the x-axis. The zeros remain the same. So this one simply goes up to 4, down. Again, we're curves. We're not doing straight lines. It looks something like that. So this green curve is our B. Now that we flip-flop to the negative, now we're going to be doing some reflecting over the x-axis. So now we know the height is still 3, but it's in the opposite direction. So our 0, follow the red. I know it's kind of hard to see it on here. Here's the red at 0. So instead of being at positive 3 when we get to pi over 2, we're going to be at negative 3. Then we get to 0. Instead of being at negative 3 at 3 pi over 2, we're going to be at positive 3, and then we're coming back again. So what this looks like is this, and most of the time, once you get this part of the curve, the rest of it just seems to follow suit pretty nicely. Like that. So this is our C. And now we're going to have the same thing with D, but it's only going to be a half. All right, so let's pick a yellow. Let's pick yellow. Negative 1/2 means we're going to follow the same curve as the C. So it starts at 0, but it only goes to negative a half. All right, so 0, positive a half, 0, negative a half, 0, positive a half, 0. So this one is a really little curve like that. So that's our D. Like I said, doing this with colored pencils or markers would make things a little bit easier. Make sure it doesn't bleed through to the other side of your paper, though. All right, so that's it for today's lesson. Kept it under 15 minutes today, which is great. Please make sure you're understanding these curves and how the negative affects and how the amplitude affects the curves. Okay, so that is our objective for the day. Until next time, always make good choices.